Depletion of energy sources. We eat food for energy. The fats in the food are broken down into fatty acids. The proteins in the food are broken down into amino acids. The carbohydrates in the food are broken down into glucose, meaning that the ATP-PC can be created, which is then broken down into energy and used in the sliding filament theory, allowing our muscles to contract. This means that the more carbohydrates in our food allows us to make more ATP, meaning we can run for longer. This is very useful for a long distance runner, as they will eat food with lots of carbohydrates before a race. The amount of glycogen in our body decreases when we exercise. This means that we have to use fats, meaning that we cannot go as fast as usual, causing fatigue. Phosphate creatine, PC, is our source for ATP, as we break down PC to create energy, to then bond PC with adenosine diphosphate, ADP, to create ATP, which means we can use ATP for the sliding filament theory to make our muscles contract. However, our PC begins to run out, which means that we have to move on to a different process which doesn't involve PC. This then means that we move on to the lactic acid system. The lactic acid system uses glucose and glycogen instead of PC. However, the lactic acid system is a much longer process, meaning our muscular contractions are slower, causing fatigue. After a while, we then begin to run out of both glucose and glycogen, meaning we have to move on to a different process. This process we move on to, the aerobic system is still using glucose and glycogen, but also oxygen and fats, which we use as another energy source, which is even slower than using the glucose and glycogen, meaning that this system takes even longer for our muscular contractions to happen, making them slower, resulting in even more fatigue. When exercising, our body's acidity levels increase with things such as lactic acid and carbon dioxide. When our acidity levels increase, our bodily functions cannot work as quickly, meaning processes such as the Krebs cycle and ATP-PC system will function slower, because as our body moves on to the lactic acid system and then the aerobic system, the process of making ATP takes longer to create, resulting in fatigue. Neuromuscular fatigue. During exercise, our body has a depletion of acetylcholine. This means that the neurotransmitter that tells our muscles to contract cannot work as quickly due to there being less of it. This results in fatigue, as our neurotransmitter is telling our muscles to contract at a slower rate. There is a reduced calcium ion release during exercise. This means that the reduced number of calcium ions results in slower contraction rate, as they are used to in the sliding filament theory, meaning with a reduced number of calcium ions there is a reduced number of muscular contractions, resulting in fatigue. Recovery. Excess post-exercise oxygen consumption, EPOC, is a recovery period after exercising or physical activity when we are still breathing heavily after finishing our physical activity. EPOC is a recovery period that is intended to recover the oxygen loss during exercise and erase the oxygen deficit. Fast components. After exercising, we need to restore the muscle phosphagen stores in our body, as they would have all been used up. We restore our muscle phosphagen stores by using oxygen. This is done in the EPOC recovery period, as 99% of the muscle phosphagen stores are restored within about 3 minutes. After exercise, the build-up of lactic acid is removed by oxygen. This is because lactic acid causes cramp in our muscles and is bad for us, and can cause DOMS, delayed onset of muscular soreness, meaning that we need to remove the lactic acid, which is done within the EPOC recovery period. Slow components. During exercise, our myoglobin stores use all of their available oxygen to the working muscles in our body in order for them to function. This means that after exercise we have to replenish our myoglobin stores for the future. This is done during the EPOC phase, as we continue to breathe heavily in order to replace the oxygen lost during exercise in order to replenish all of our store, especially the myoglobin stores. During exercise we use up the glycogen in our body, meaning that we need to replace the loss of the glycogen. This is done through eating, as when we eat we break down the food in order to replenish the glycogen loss in our body.